Hello, PreCalc. March 2nd, so you'll be watching this after Thursday's class, which will allow you a choice of Friday, Saturday, or Sunday. So I will keep it short and sweet. We'll do one problem called exponential growth and decay, because I know many of you are busy bees this weekend. The equation that will dictate our work is an exponential equation, and whenever any variable is showing exponential growth or exponential decay, we are going to use this formula. So you'll look for those words in the problem. What this means right here is the amount at time t. So we're going to have some amount of something, maybe bacteria growth, and we are told that it's growing exponentially. So we know this formula. When you see the word exponential growth or decay, you know this formula will be put to use. So the amount at time t is what that stands for. This is the amount at time 0. So that's what you have to start with. And E is our friend. E pops up so many places, and it's popping up at exponential growth and decay. So E is E. K is a constant. And T is time. The time here will match the amount at time t here. So this time will match this time. These won't be the same number because this is the amount at this time. So I'll make this t look more like that t. So these are the same times. This is the amount at the time stated here. Alright, so I'm going to have to erase those decorations. You have them in front of you, so that's good. And now I'm going to show you the problem on a worksheet. And I'm just going to get it into the view of the camera. And I'm going to ask you to write that down. This one that starts out, I'll read it to you. Hits on a website. That's when I want you to write down that problem. I think it's showing up pretty well. Hits on a website. So you have to pause to get it down. So hits on a website each month are modeled by this formula. So I'll jump right to it. A sub t equals 4080 e to the kt, where t is the months. So we're talking about t being time, so t is in months of operation. In the third month, month equals 3. In the third month, there were 10,000 hits. So I took a note from the problem there. Find k and use k to find the number of hits in 24 months. Alright, we'll do this one problem, and we will recognize that that pattern will be repeated with other exponential growth and decay problems. When you have exponential growth, the growth will follow the curve like this, and when you have decay, it'll follow the curve like that. So we've already graphed exponentials before, so that's the kind of problem that we're tracing now with mathematics instead of a graph. Alright, so the first step, these are two-part problems, and the first step is always to find k. So here we're going to say find k on the first part, and then we're going to use k. I mentioned that k is a constant, and it's different for every problem, but once you have k for the problem you're working, it stays the same throughout that problem. Alright, so let's find k for this. Well, we usually find k in some piece of data that they've given us. And so here they've told us at month 3 there were 10,000 hits. That's all we need to find K. So let's plug these values in and solve for K. The amount at time t, 3 months, was 10,000 hits. So I'm going to replace A sub t with 10,000. It equals 4,080. E to the K is what I'm looking for, so I'll circle it. And T is the time where there were 10,000 hits. So we're doing this in terms of months, so we have a 3 there. Alright, in order to solve that, we are going to solve an exponential, which you have been well taught to do. So, excuse me a minute, I'm going to get my calculator. Dramatic pause. Alright. To solve this exponential, you'll recall that the exponential, before we can bring the unknown down where we can work for, we have to get rid of this 4080. So we're going to divide both sides by 4,080. 10,000 divided by 4,080 is 2.451. And now that equals e to the 3k. I'll write the 3 first. So now we're in familiar territory. We learned how to get the k down. We were used to working with x's, but it's just the k. So how do I get it down where I can work with it? Well, when the base is e, I end up taking the ln of both sides. So we've done a number of exponential equations that we have solved already. So ln of 2.451 is found on your calculator. It's 0.896. And this is base e. So what exponent do I give e to get e to the 3k? So it's like this is undone, and we just get 3k. Divide both sides by 3, and we get k is 0.299. So that step 1 is finished. So now I'm going to use k. So I'm going to rewrite this equation, but when I get to the k, I'm going to put in the 0.299. So the amount at time t is 4,080 e to the 0.299 t. Alright, so now I'm going to use that k to answer the problem. So the question says, in 24 months, how many hits? So we are looking for an amount at 24 months. So I'm going to write it like that. Amount at 24. A sub 24 indicates to me that I want the amount at 24 months. It equals 4080 e to the 0.299, but we know the time because it was given in the problem. The question part is 24. So the amount at 24 is simply tapped into your calculator. I would suggest doing the e raised to whatever this product is first, times 4080. Whatever order you can get to work it out, and it'll come out to be 5,335,282 hits. So you can see how this is growing exponentially. It got up to a lot of hits very quickly when there's exponential growth. Alright, so I hope that you have the strength to come in tomorrow and remember some of this, or come in on Monday and remember some of this. So till then, that's all for tonight. Have a good rest of the weekend and catch up on your rest. Alright, till Monday. Goodbye.